This is a repair on a ion gauge controller that's being used in the Agilent GC mass spec system. And our philosophy in chemistry is that it's a hands-on subject. And I do want to preface that this video is an actual account of the actions performed. The repairs you see, although somewhat choppy in sequence, are done in real time. This video is not meant to guarantee, grant, issue, or imply any license warranty for any of the actions performed as a result of viewing this video, and it does not indemnify any individuals, organization, or group. If you do any actions after viewing this video, it's your responsibility. It's your decision as to what you do. And that's what chemistry is about. This video is an actual account of the repair actions performed. Nothing was staged, and it was done in the lab. So the background hissing that you hear is due to the volume of the airflow in the lab. This is an Agilent GC mass spec system, and it has a problem. The ionization gauge controller displays erratic and unstable readings. If we try and turn it on, it will act like this, bounce all over the place, never stabilizes in a reasonable amount of time. And if we look at the tube, see that pulsation? Not good. And a good gauge is going to act like this. Reads right away, and the gauge is not pulsing. The gauge tube is not pulsing. So those pulsations may be due to power fluctuations to the ion gauge. So we're going to take this baby apart. And the easiest way is to take out the two Phillips screws. So we take out these two screws. And we're going to pull this baby apart. It slides out. Alright. And take a look at it and open the case innards and see these 3 capacitors. We're going to remove those and replace them with new capacitors. Okay, I'm back. I'm going to remove the old capacitors, and we want to make sure that we note where the positive lead goes. So these are the three capacitors we're going to change. Let's see if we can get this in focus here. I guess we can't get this in focus very well. Alright. Anyway, where the black stripe is on the orange, that should be the negative. So you want to note when desoldering those leads where that is. Okay. Alright. Here are two capacitors are removed and in the process of replacing them, and if you look carefully on the printed circuit board, you can see a little plus where the positive lead holds. And now we put the case back together. And let's see if it works. Good gauge is on the right, repair gauge is on the left. Let's swap cables and see. Okay, moment of truth. Power on. Ignite. Oh, look at that. Not too bad at all. Not too bad. My compliments to Department of Chemistry, University of Washington, for this trick, this repair trick. Half an hour after powering up, reading is stable. Looks like repair is good. Thank you, UW. Okay, the 2-week follow-up. Unit's still working fine. And just to give a clarification, the old capacitors were tested and their capacitance was low as compared to what their original one was. And if we had tantalum capacitors that were suitable, would have used them instead, because aluminum electrolytics typically only have a useful lifetime of about 20 years. So replacing this batch after 15 expected.